Okay. How to make a forecast. How do we make a forecast, and how can we make it useful? I think the old common theory is the meteorologists and climatologists are basically just like agricultural economists. You know, we get paid to be wrong, and people keep asking us for our thoughts, even though claim we're only better than 50-50 in terms of a forecast. But in reality, when you start to look at long lead outlooks, there is some predictability within them. And the trick is knowing how to interpret them and where you can get that information and how this all plays into the overall scheme of your local climate. And I have to caution, your local climate. The only way that you can make effective use of long lead outlooks is to have a very good understanding of the precipitation distributions in your given region of the country. You know, I'm going to give you some examples today using the Nebraska case scenario. They may not apply to Michigan's climate. They may not apply to Oklahoma's climate. Each of us have a uniqueness in terms of our climate, and that's not only based on your position in relation to the Gulf of Mexico, but it's also relative to your latitude. And the other underlying condition that we talked about briefly here earlier is, of course, the soil types that you have at your underlying surface, because that dictates the amount of moisture that you can potentially put into your profile that would be available in terms of agriculture. So let's take a look at the annual precipitation. And this is just basic climate, but you'll notice that the primary area of the country that sees a significant amount of moisture is located in the eastern United States. Let's just ignore the western United States for right now. What is the primary source? It's the Gulf of Mexico moisture. And as that moisture feeds northward, of course, systems can work on it. We can drop precipitation. This gives us an annual basis, but it doesn't tell us the timing of the heavier precipitation events. You'll notice to our west that it is a fairly semi-arid environment, and unfortunately, those areas located in the high plains region from Texas to North Dakota can be just as dry as the Southwest. Well, not quite as dry as the Southwest, but can have the same type of climate scenario as the Southwest. In the same token, in any given year, we can be just as juicy as portions of eastern Iowa and western Illinois. So it really boils down to the overall atmospheric setup and how systems move across the country in relation to your position and how that moisture is evected into your region. Now, it's very difficult for us to forecast a given storm system more than a couple weeks in advance. We haven't gotten to that point yet. Models are getting better and better. You know, most people, when you talk to farmers, say, you guys still can't predict. But if you look at the change in how forecasting across the United States has changed since I started my career at Iowa State, we were talking about the ability to predict accurately maybe 2 or 3 days into the future. The reality is we can predict fairly accurately now a good 7 to 10 days into the future. We may not get the exact precipitation coming out of the storm system, but the models consistently now can run out to 17, 18 days. And what you do as a meteorologist or a climatologist, you're always looking for a consistency in trends of models. So when we look at long lead outlooks that are put out by the Climate Prediction Center, it's really no different of a scenario. We need to focus on how the consistency of those models are dictated, and then we can delve into the bare bones facts of how to make predictions in case we're looking at needing additional moisture or we're looking at periods of drought that may be arising. Look to our west. The major feature you're going to see is that we have a line of mountains that run essentially from Alaska all the way down along the Pacific Ocean. And we in the United States are in the westerly region. That means our air typically is going to move from a west direction to an east direction. When you get down into Florida, again, that becomes more of an easterly component because you're in a different, as Ken mentioned earlier, you have the circulation patterns that favor certain ways that the mean winds move, and those are from the east to the west as you get from the equatorial region up to about 20, 30 degrees latitude. So with those mountains there's a unique environment that we have here that you don't see in Europe, where most of the mountain ranges lie from east to west. And that is, those mountains are very efficient at extracting moisture from the Pacific Ocean, and we see most of that moisture fall on the windward sides of the mountains, The lee sides tend to be much drier as that moisture is stripped out. So if those mountains weren't there, our environment here across North America would be a completely different scenario, because we would not only be tapping the Gulf of Mexico moisture, but we would have a more consistent feed of moisture across the western United States. As that moisture would move in, it would be stripped out. So this distribution of precipitation wouldn't be as sharp. If you look at Europe, there is basically a maritime environment where they're in the westerlies. They're getting that ocean moisture, moves all the way across Europe, and the separation of those mountain ranges allows the cooler air in the European areas to be separated from the Mediterranean region, where you get the higher, hotter and drier situation. So let's look at the precipitation distributions. The one thing that we do know here in the western high plains is that the winter period represents our true driest season. Now, if you get into the upper Great Lakes region, where I'm originally from, that area relies significantly on snowfall as a major component of their overall climate pattern. And we hear a lot of things about the recent low levels, or record low levels, on Lake Michigan and Lake Huron. It tends to be cyclical because it's dependent on that snow basin as a feeder source for the lakes. So one of the things that we watch as we go forward in time in this region is whether or not we are going to see an overall mean reduction in the snowpack in that region, or is this a temporary phase in an overall general pattern where we see highs and lows. After my father retired from the military, we moved back to Michigan. Back in the early 80s, we were dealing with unusually high lake levels. We had went through a period of extreme snowfalls in the 70s in the upper Great Lakes, regions. That snow melt was an important source. It also was an important source for keeping drought at bay. For our region here, the importance of the winter is not nearly as significant as most people play it out. We all want to talk about how much snow we're going to get, breaking droughts. But the reality is, off-season precipitation is more important in the fall and the spring than it ever was in the winter. Now, when we talk about the possibility of climate change, that may change the dynamics, because typically, when we get into the winter period, we deal with frozen soils from the northern to the central plains to the north. If the climate is going to warm into the future, all of a sudden those events that typically may not have had a major impact on soil moisture becoming of greater and greater importance. And if you look at the last 10 or 15 years, one of the major things that we've seen, at least in a temporary sense, is we're getting warmer events in the December period that are coming in the form of rain. And before, with those soils frozen, of course, we get a runoff component. So we're actually getting much more of a significant component of soil infiltration from rainfall and moisture infiltration than we did previously. So the dynamics may be changing. As this trend continues in the future, it's very possible that a considerable portion of the Central Plains moisture will be going into the profile and become less of a runoff component. Why is that important? Water is a very valuable resource out here, and of course, some of that runoff component that's necessary to fill our stock ponds in the wintertime from that runoff from snowmelt in the spring may be lost because we're going to absorb it into the profile. That also sets up the condition that if you follow it up with very early spring storms, you get a greater runoff component and you have a higher erosion potential if your soils are saturated instead of basically being dried out as you get into the early part of spring of the surface. Now let's look at May. May is probably the most important component for a lot of the precipitation here in the Central Plains. We rely on that moisture to give us an additional boost to get our crops going. And you can see that there's a fairly wide distribution of precipitation. All these blues would indicate, these dark blues would indicate precipitation in excess of 4 inches during the month of May. And in fact, if you want to break it down into a more seasonal component, what you'll notice here in Nebraska is you can see that there's a large swing in precipitation from the southeast to the northwest. Generally here in Nebraska, and it's very similar in Kansas, Oklahoma, North Dakota, South Dakota, is that we're going to see this big shift as we get closer and closer to the Rocky Mountains. And here in Nebraska, typically about an inch for every 25 miles you get from the southeast to the northwest, and how much you're going to drop off your annual precipitation. But the most important component is when you start looking at the seasonal distribution of precipitation. 8% on average here in Nebraska represents our December through February precipitation on an annualized basis. So it is not a significant component. But once we start getting into that March and May period, you can see that that becomes very important in terms of establishing soil moisture. And the reason it's important is because primarily if you look at the history of corn production here over the last 20 or 30 years, typically you've seen our mean planting date in Nebraska shift forward. When I say forward, I'm shifting back toward April by up to 7 to 10 days in most locations. That's another week of precipitation we've lost. In the context, that's an inch of moisture that we're probably starting to lose in terms of the crop using it earlier than putting in the profiles in terms of the storage component. It also means that as March through May turns out to be a bust, we have to make up that precipitation in the summertime. Otherwise, we're going to have to increase our irrigation here in the western high plains. So when you look at it, you only receive about 40% of your precipitation during the June through August period. So if you're short during that spring period, the component has to be made up in the summer, and it gets progressively more difficult to make that up in the summertime. Now, when you look at it in terms of what we describe here in Nebraska in terms of prospects for drought or prospects for a very good year, we're looking at that component from October through April. Why October through April? Well, typically, we're going to harvest our crops sometime during the month of September into early October. So we always pick an October date because in the most vast majority of cases, our crops are fully matured. So what falls, we have a fairly good idea is going to get into the soil profile. Now, when you look across the components of the Midwest, and this would go to the South, your clay, your silty clay soils are going to hold anywhere from about 1 3/4 of an inch to about 2.5 inches with a pure clay soil of available moisture per foot. So, that fall and spring recharge, it gives us the ability to put moisture into our profile. And what we're hoping here, like in eastern Nebraska, is we want to see 12 inches. From the time we get from October 1st to the end of April, we have a fairly decent shot that we're going to get the possibility of average yields with normal precipitation. We have found that about 70% of the precipitation that falls during this period will eventually make it into the profile. Now that's an average. In one year it may be a little bit less, in one year it may be a little bit more, depending on the type of precipitation you get. The same type of soils here in eastern Nebraska at the same time you see in Iowa and most of Illinois during the major portion of the Corn Belt. So it's an effective way to measure how well your profile is getting full. Well, if you're only getting 28 inches here in Lincoln, and you would take and effectively take 70% of it, it gets you perilously close to that 24-inch or a little bit below that 24-inch mark that typically we would expect to grow corn in and have fairly decent results. But the farther east you go, they can get by with a little less precipitation, a little bit farther below normal, and still effectively grow a reasonable crop. That's the reason they pay a little bit higher premiums on their land prices, because the average yields in these regions are considerably greater than they are in this region, where we tend to be a little bit water limited until you go west of us, where, of course, we supplement with irrigation. So as this fall and spring recharge period goes, so goes the ability for that irrigated person to make a determination of how much it's going to cost them to apply water under average conditions in the growing season. If you're running a 3-inch deficit, it's got to be made up somehow. And generally that is, you're going to have to apply additional water. And so all of these things are very important components in the overall aspect of trying to make a prediction going forward. Now, I'm not going to focus on this. We're going to go into some websites here in a little bit, but these are the 4 major links that I think are probably most useful for you in terms of making forecasts going into the future. Of course, the Climate Prediction Center is the official forecast for the United States in terms of our outlooks. These outlooks are issued, basically, your long leads are issued once a month, but your 30-day forecasts are issued twice a month. And I'll go into a little bit more detail about that. For the Western High Plains, in my career, one of the most important criteria for your vulnerability to drought is the overall snowpack to the regions immediately to the west of you and to the south of you. So if you're in Kansas, you're going to be concentrating on the snowpack across the southern Rocky Mountains into the central Rockies. If you're here in Nebraska, you're going to be concentrating on that central Rockies region. And if you're in the northern plains, the most important component is from the central Rockies to the northern Rockies. Why is that important? Because that snowpack is a valuable moisture source not only for your filling up your reservoirs, your stream flows that are emanating and moving down toward the Gulf of Mexico, but they also keep the ability from the atmosphere from overheating and drying it out too quickly and cutting off a source of moisture that's very valuable until the monsoon season kicks in. And if you look at the precipitation distribution in the western high plains, the one thing that's unique about it compared to eastern Nebraska or eastern areas of the high plains region is that they end up getting what we call a double spike in precipitation. Here in Nebraska, we spike our precipitation during the months of May and June. They're almost fairly similar. As you get into western Nebraska, you see your spikes in your precipitation during the month of June. You drop off during July, and you see a secondary spike during the month of August. What is causing that secondary spike? It's that monsoon that comes from the southwest that lays that moisture funnel up into the western high plains. And so that snowpack acts as a bridge, essentially, between when the thunderstorm activity starts to diminish in the month of July to when the monsoon kicks in the month of August and starts shutting that moisture up in the western high plains. So if that snowpack disappears earlier, you're increasing the bridge between the monsoon and when your thunderstorm activity diminishes. And one of the things that I found very consistent here in the central and southern plains, I have looked a lot less to the northern plains because honestly it's not an area that I'm too concerned about, because my responsibility lies here to the people of Nebraska. But what we found is a snowpack below 80% here in the central plains as we get to the 1st of May from an NRCS release typically would signify that we're going to see some drought implications across the western portion of the United States. Easiest forecasting tool you can ever get. April 1st, we look for 70% snowpack. You say, well, why 70 and then the other one 80? Because April is the biggest snow season in the central Rocky Mountains, and it's very common to see a big snowpack develop during the month of April with these late spring storms that are very common during the April period, and those have a very high moisture content. March and April are the two big months in the central Rockies, and then that shifts northward as we get into months of April and May across the northern Rockies. Essentially, here in the southern Rockies, your snow season is just about over. You've got about another month and a half, and then as that goes, so goes the chance for your weather. The other major pattern that has the highest predictability in North America, outside of any other forecasting tool, is looking at the signature of El Nino and La Nina conditions in the equatorial Pacific. In fact, the Climate Prediction Center's models are heavily based on these conditions. And if we are to believe what they do indicate to us, their forecasting ability jumps to 60 to 65% when these conditions exist, and they're no better than a flip of a coin when these conditions are not in play. And you hear more and more about these conditions as we become very much more cognizant of their overall impacts. What exactly is happening? Essentially, as you look at the area from, excuse me, from South America over toward Australia, we're looking at the equatorial region. That's an area of convergence. That's where our Gulf, your sea surface conditions, your Gulf currents come off the North America, western side of North America, run down the western coast, and they intersect at the equatorial region. Conversely, when you look at the southern hemisphere, they're coming up the western coast of South America, and they also intersect, and then the surface configuration, high pressure and low pressure systems, basically dictate how strong that current is going to move that water toward Australia. So the stronger that current, the more cold water is going to be pulled across that equatorial region toward Australia. The weaker that current, the less of that cold water is going to move that way, and you tend to see your temperatures increasing at the surface. Why is that important? Any time that the equatorial region has above normal temperatures at the surface, you're going to get additional atmospheric moisture released into the atmosphere through the evaporation process, and systems coming across the Pacific Ocean are able to tap that moisture feed and juice up systems coming into the western United States. When it's cooler than normal, typically you're going to see a reduction in the amount of atmospheric vapor in the equatorial region, and that's going to weaken systems. Now, the big player for the southern plains has always been the El Nino La Nina signature. And typically, when you see the responses here to these conditions, it's an indication that at least 70% of the time, these conditions will materialize. It doesn't mean they're going to occur all the time, but for the overall probability of looking at climate returns, this is the trends that typically we're going to see under those scenarios. The stronger the El Nino or La Nina signal, the stronger these effects are likely to occur. So for the southern plains, the most important component in holding drought off is periods where you have a high return of El Nino signatures. And if we look at the most recent 10-15 year period, as we've seen the drought really start to materialize across the southern plains and becoming a semi-permanent feature, what we have to look at is what the Pacific Ocean has been doing. And we've been going into a high return period of La Nina events. So essentially, when you look at the bottom graph under La Nina, you'll notice that that blue indicating the most dominant jet stream is your northern jet. It tends to pull much colder air into North America. It weakens that subtropical jet that brings those storms through Southern California and across the southern United States. So, if we had an overall scheme projecting forward, irregardless of what our numerical models say, we would indicate that because the Pacific Ocean has gone into what we call a cool phase and is expected to last somewhere in the 20 to 25 year time frame, there should be a higher incidence of these La Nina events, and therefore we have a higher incidence of drought susceptibility across the southern plains. When we return back to a warmer phase, then we'll see an increase in precipitation across the southern United States. Now, when you look at the precipitation probabilities of the last 30 years and look at how precipitation has changed, one of the things you'll see in the southern plains is they didn't have the extent of droughts that they have this most recent trend. We were in a warm phase during the 70s through most of the 90s, and that really led to much more significant El Nino events. And so those were very conducive to better cropping decisions and better cropping practices across the southern plains. Now that we're seeing a movement toward a La Nina pattern, the expectation is we're going to see much more significant snow impacts across the northern Rocky Mountains. If you look at that jet, it's bringing that cold air down. That cold air is basically shunted up against the Rocky Mountains. You lift it, take out what little bit of moisture is there, but it all begins to accumulate at a greater extent. And we tend to see higher flooding incidents. So when you look at the impacts of the Missouri River flooding that we've seen here a couple of years ago, we had a second consecutive year of La Nina with high snowfall returns that led to the extreme flooding conditions. So those two bases are really what we look for in terms of forecasting ability, and that's what the Climate Prediction Center is incorporating into a lot of their forecasts. They also use some statistical analysis, but the overall scheme is that these are the most important components. Now, typically these events are most prominent in the northern hemisphere during the winter because that's usually when the event is established, and at that point we start to see a weakening trend as we go into the summer, and if it's going to reestablish itself, it'll typically reestablish itself in the late summer to the early fall, and we can go into multiple year events, or we can switch back to neutral. The southern hemisphere has a much better relationship in both fall and the winter and their summer periods than do the North America. So again, ours is mostly confined to the winter, and the southern hemisphere is an important component in their cropping production, and especially in the winter when you consider it. This is when they grow their crops. So the impacts can be very devastating, and that's why the commodity markets pay particular attention to the weather in the southern hemisphere and whether we're in an El Nino or La Nina. Australian wheat has a much greater tendency to see below normal yields during, during El Nino type events, and during La Nina events they tend to see above normal yields. South America, you can see it during a warm episode. We see a warmer incidence in Brazil. Typically, of course, we do worry about disease problems there. Thank you very much. This is what happens when you drink too much coffee in the morning before you come here. So, understanding these relationships and their interplay, really when we're looking at not only the United States, we're also looking at cropping patterns across the world. All of these, of course, we're producing crops to feed people, if we're not making it to burn or to convert into fuel. But the overall scheme is most of the production is done to feed people. And so it's very important if we look at the southern hemisphere in terms of how our crops will play out during the season in relation to their production, because it's that balance that really overall dictates long-term prices. Now when we look at the cold episodes, you can see that the vast majority of the region that's wet, and you look and see that Australia does see a wetter pattern. You see a wetter and cooler pattern in South America or South Africa. That's a high production corn area. Of course, we've got our wheat in Australia, and then of course you see your cooler conditions in Brazil. We've seen some cool conditions materialize over the last few months, and what is Brazil's crop doing this year? We're looking at fairly high productivity coming out of the soybean regions of Brazil. So, when I talk about snow forecasts, these are issued by the NRCS. They begin the first forecast released in January. The last forecast is released during the month of May. Now typically we shoot for the first Tuesday of the first full week of the month, but it's not set with NRCS. It can vary about a week. Generally you'll see those releases come out on a Tuesday. So if you go on and they're not on a Tuesday, then generally they're going to come out the next Tuesday. Now this year they threw us a curve. It was supposed to be out on Tuesday and they threw it on Thursday. But we watch these with keen interest because these really are an important criteria in terms of our forecasting. So this is your latest snow release. So if I was to make a forecast, not even looking at what the Climate Prediction Center was indicating for the next few months in terms of their forecast, I could look at this snowpack and say that if this doesn't change, western Nebraska and the southern plains are likely to see a high period of drought coming up this summer, irregardless of what the climate conditions are, because we do not have a sustained snowpack. And again, that magical 80% snowpack is very important. Now these are done by basins, and you will notice from central Wyoming southward, there is no basins that are essentially below 80% on the eastern side of the Rocky Mountains. We can get above normal snowpack on the western side of the Rocky Mountains, but understand, this is a different type of snow pattern there than on the eastern side. It's a drier, fluffier snow. Everybody likes to go to Utah to snow because it's that powdery snow. Very light and fluffy. The inner basin heats up. It's a high desert. That moisture, basically that snowpack disappears much quicker than it does on the eastern slope where we get the Gulf of Mexico moisture and much wetter snowpack. Now if we were to look at the northern plains, we would say that right now, based on this, it doesn't appear that they're going to have any major drought problems in regard to summer dryness because there's an established snowpack that is consistently within the normal range. And then the other component that we have to look at is, okay, just because you're above normal snowpack or normal snowpack, what is your stream flow going to be? And that takes an understanding of the underlying conditions. If you're going into come from a drought year and your surfaces are dry going into your winter, you're going to lose a component of that snowpack into the infiltration. The best scenario that we always want to look for in terms of snowpack going into winter is a period of wet conditions in those regions up to the first initiation of your snowstorm, because if your surfaces are wetted, they freeze. Much more of that is going to become a runoff component and fills our lakes and reservoir. So overall, you know, the snowpacks of February 1st doesn't paint a very rosy scenario, and the expectation, of course, would be that we're going to see a continuation of drought. That's your expectations. Is there anything you can glean from a forecast? Well, you see these forecasts, and I'll show you where they are. Now, typically when you see these on the Weather Channel, and it drives me nuts when you see this, do you ever see an EC put on a forecast? Does anybody even know what the term EC means? Equal chances. These maps are not a forecast as much as a probability distribution. They're looking at what are the odds of a certain class occurring. And therefore, when you see them on the forecast maps, the whites become normal. This isn't indicating normal by any stretch of the imagination, and that's the one thing that we have to try to continually press against the public, is that this is not a normal forecast. If you want to consider it a normal forecast, you better understand the range that's going to be dictated in terms of the normal forecast. We're going to get to that in a second, because it basically becomes a probability of exceedance idea. So when we're looking at these for the common layman, what should we be looking at? We should be looking at consistency in the forecast. How do we do that? You save these files every single month, and you are looking to see if the same pattern reappears. Now, that might sound counterintuitive because you can see some dramatic changes in any given month or 2 months. But when you're looking in terms of forecasts out to the future, these take you all the way to February through April of 2014. So if I'm trying to make an educated guess in terms of our risk going forward, this is one of the things that I'm concentrating on. When I look at these each month, is the February through, well, you're going to get a new month here, February through April, but let's just say we're going to look at the April through June period of 2013. I consistently am looking at these out every month to see, is there a wholesale pattern change? If there's consistency in these forecasts, it gives you a much higher degree of confidence that they're going to verify. If they are changing from month to month for the same time periods, your guess is as good as theirs, essentially. That's a low forecasting ability. Now, with an El Nino or a La Nina type signature, you're going to see considerably more consistency in your temperature forecast. The one thing you need to know about a precipitation forecast is they are not very good in the central high plains during the summertime. It's the lowest skill forecast for that period. You're dealing with air mass thunderstorms, and we know that any little wave in the atmosphere can generate a big convective complex. These models cannot get down to that fine of a scale. Good, we're getting right there, perfect. So, what we want to do is again maintain consistency. So when we're looking at a drought forecast, one of the things this year that I'm telling people is we're finally seeing a signature move away from an overall drought pattern, a dry pattern, and consistency of the forecast. And that, to me, becomes a more optimistic selection than to seeing a consistency in the forecast going forward. So how can we get an idea of what's going on? This is called a probability of exceedance forecast. I'm going to show you where this is located on this Climate Prediction Center's website. And they're done by unique cluster divisional. It basically is divisions, but they're taken out with areas that have uniqueness within that region. So they may cover a climate district, or they may cover 2 climate districts. And we'll get to that in a second. But essentially what this is showing you is several things. Let's see if I can do this. This curve is your typical probability curve. Now you'll notice that there's no black line here. If there is a forecast for your area you're selecting, and you do have a probability of having a greater probability of drier or wetter or warmer, you will see a black line that will come in here, and it will shift the probabilities for you and give you a new recalculated confidence intervals with what you might expect to see. So this is for northwestern Iowa for the next 3 months. So we're going to make the northwestern Iowa people happy here. And this also includes southeast South Dakota. Point forecast, 5.54. That's basically the mean forecast for that region, for that 3-month period, for that entire region. Essentially, a 50% confidence interval. That's pretty significant confidence interval. They're expecting anywhere from 4.23 to 7 inches within that division. The 90% confidence interval says that we should expect at least 2.61 inches to 9.34. So there's a 10% probability that's going to probably fall below that average. Now, the probability of the highest 10%, they basically are saying 10% because there's been no adjustments here. This is where you'll start to see your probabilities adjust. They swing them up or down. So if it's a drier forecast, you're going to see that probability level shrink below 10%, and you'll also see the value change. The center mean is 5.71. The mean and the mean and the median are very close. And if you look right down here, see this little star? This is over a 30-year period that we're looking for in terms of this probability. But what it is doing is weighting the most recent 15 years in your period. And then each of your significant years are indicated of exactly how they fell out for this division. So you can kind of get a precipitation distribution over the last 15 years. If you're inclined to believe that the most recent 15 years is more of a function than the previous 30 years, in the climate change scenario, probably the most 15 years gives you a better trend than the last 30 years, especially if you do think that we are going to continue to see an upsloping temperature trend as we go forward in time to temperature changes. Now, you can see the same thing in terms of temperatures, and you'll notice that there is no temperature distribution. It does give you a kind of a real outlook in terms of how things have functioned. And if you do think that this last year was highly unusual, I would point you to that little 12 right there, and look where it lies on that probability distribution. We were so far outside of the class this year, it wasn't even funny. But in the same token, 4 years ago, we were way down at essentially, 31 degrees. And if we take this line, we were basically sitting at, what, 10% probability level? Is that right? Yeah, we basically 100% probability, 26. Take that all the way up to an intersection curve. Here we go. We were basically way at the other end of the spectrum. So you kind of get extremes here. Here's a case where we're looking at the southern plains. And this is where I'm getting about the probability shifts. And this basically recalculates everything. Explore these because they're real good. Now, these are based on divisional. I'm going to show you a site where you get these. How do you calculate it for a point location? Well, Martha's going to probably show you some areas where you can get data from the High Plains Climate Center on the online for probabilities. The other thing is, look at your distribution. So when we look at this distribution, we're looking at a confidence interval of 48.67 to 53.5. And we look at the mean typically is 51.04. Look at the mean for that 3-month period for your location. All you have to do is look at the difference of the temperature from that, calculated in terms of percent difference. You can subtract and you get a fairly accurate measurement of your totals. Is this ready to go on the internet?
Well, you're almost
out of
time, so
okay.
5 more minutes.
5 more minutes? Okay. We're going to take you to, the climate prediction is the most important site. I hope I didn't screw anybody up right there by doing that.
Can you add a new tab so we don't lose this site?
Yeah. Maybe. Go ahead and load it up, and I'll bring them to this site where they can see this. Yeah. That's the fastest way. There we go. Okay, this is your typical CPC website. Under, we don't like this. I hate these things. Under index, under Outlook products, you're going to see a whole bunch of links here. And it is a little bit much, but this does tell you how they use their data, but it gives you your schedule, and then we're looking for these are the color version maps. So this is a quick way to get to your color version maps, but you can also do this in terms of frequency, probability of incidence outwards. So let's look at a temperature outlook. Okay, this is what you end up seeing in terms of a forecast. Okay, so let's take a look at just a temperature forecast for the next month. Okay, here's your temperature forecast with your probability strings. Down underneath it here, and I apologize for not getting this done, you'll see that these are broke out by specific climate zone areas. So if you want to get a fairly robust idea, let's look down, we'll get somebody from, say, north central Oklahoma. There you go. This is where all this data is coming from. It's one of the most effective tools I can think of to give you an idea. The one thing you always hear about on a meteorologist on TV is that we're below normal. If you notice, normal here is a whole different concept. It's not a single value, it's a range. And it's that 33% middle, essentially, that you're taking. And you're looking below and above. So, really, in terms of the Climate Prediction Center in terms of climatologists, normal to me is not a tenth of an inch below our 3-inch mean for that period. Normal is, am I within that maybe 2 to 5 inch range that is dictating? It's only below that area when you start to see that below normal signature. That's what it's indicating. We're shifting toward the lower end of this basic premise. The other thing is that it's very difficult for a lot of the public to understand this simple concept in terms of forecasting, and then I'll end it. When you have a 33% category in each one, and you're shifting on a forecast, it says you have a 40% probability, it is essentially taking from your lower end and shifting it to your higher end. So let's say we shifted to a 40%. That adds 7. That means it's 40. That is 40% above normal, 33% normal, and then you subtract that 7% from your below normal. Now, this is what confuses people. When you want to ask if it's going to be normal to below normal, and you add those two percentages up, they're going to be over 50%. In the same token, you can say it's going to be normal to above normal, and they're also going to be above 50%. It's very important for them to understand what you're trying to relay to them. It's not normal, it's 2 classes, and that's for the probabilities are going to increase. Well, the higher those probabilities, the more certainty. What I will say on these forecasts is any time that you see a probability level above 40% on these maps, that's a very strong forecast. It's very rare to see them get up to the 50% mark. If you get up to 50% mark, it's almost a certainty the event's going to occur. That's a very high forecast skill because you essentially are taking 17% away from your below normal category, so you're basically saying only got 16% chance of seeing the below normal temperatures. So I encourage you to visit these websites and play around with them. If nothing else, just watch for consistency in forecast. And as you get better indications of the impacts of sea surface temperature, you're going to see these models improve. And I think that's the one area that we're significantly lacking is the ability to do out into the 6-month, the 12, 18-month time frame, because that's where a lot of decisions are made, not only in an agricultural sense, but in a water management sense. We're not worried at this point, for the health of the system, we're worried 25 years on the road. But in terms of relaying information to the public about the intensity of certain situations occurring, these are the most important criteria that we can get, at least to get prospects into the near term. Thank you.